Welcome, I'm Mr. Gige Jeremiah Nyaga, National Polytechnic. I'm presenting on IP subnettings. We have a diagram to explain on subnetting. This is visualization. In subnetting, we have a main subnet. Then we want to introduce others like admin, student, staff, and security. So this kind of implementation of IP addressing, it helps us to reduce traffic, and also it helps us to improve network performance. So you can have, for example, a VLAN 30 dedicated to students, then VLAN 20 dedicated to security, and then you have VLAN 40 dedicated to staff, and then VLAN 10 dedicated to admin. In IP subnetting, it is good we know the following, that when you have an IP address, for example, this one is a decimal representation, 192, 168, 0, and 1, then this one can also be represented in binary as 192 is this number, then 168 is that number, 0 is that number, and then 1 is that number. Then what we call the prefix or the subnet 255, 255, 255, 0 is represented by all ones, all ones, all ones, and then zeros. This lesson is for someone who has a prior knowledge on subnetting. So let's focus on the long division method. And in the long division, as I've said, this lesson is for someone who is familiar with subnetting. So this method is, we are familiar to it. We call it decimal to binary conversion. And once you convert, you have the most significant, then the least significant, and this is the binary representation which we have at this point. So again, the 168 can be represented using this one, and then we have it as in its decimal representation, and then it's binary. The zeros is converted to binary is that, and 1 is 10. So the subnetwork mask, how we are coming up with all ones in our previous page, is the 191, the 111. This is how we come to it. Then we have this we call the position chart. It's also another way of coming up with an IP address in a binary conversion. And for example, from this end, we have 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, 2 raised to power 7, 2 raised to power 7, that is 2 raised to power 7 is 128, 2 raised to power 6 is 64, and you have that 2 is equals to 2 raised to power 5 and 16 2 raised to power 4. 8 is 2 raised to power 3 and 4 raised to 2 raised to power 2 and 2. This is 2 raised to power 1 and 1. That is any number raised by a 0 is a 1. So 192 is simply an addition of 128 plus 64. And if we have 128, that is a 1. 64 is a 1, and the total is 128 plus 64, you get 192. So if we have now 182 added using these weighted values, the rest ends up being zeros. So 168 is an addition of 128 plus 32 plus 8 gives us a total of 168. Any other number that has not been included in that, it becomes a 0. And then a 1 is all other numbers are zeros until you come to 2 raised to power 0. Then you have 255. 255, he says, is a full, so it's 1, 1, all the numbers 128, 64, 32, then 16, 8, then 4, 2, and 1. If you add all those numbers, they're going to give you 1. So another important operation you need to understand in this area of subnetting is what you call the adding operations. And adding operations simply means you multiply. So we have this number 192.168.0.1. We call it a prefix of 24. This one can be represented in this way. This is for this portion, and then 24 is for this portion. The 224 is exactly what we had presented. When you have a 255, we have its binary representation as such, and also we had this representation area where we had the same number, but now 255, 255, 255. This one is just an equivalent of a representation of the same. They just means the same. So it's good to mention that we have what we call the adding operation is simply like 1 times 1 is a 1, and a 1 times 0 is a 0. So all ones, whatever we have, represent the network portion, all ones, the subnet mask, and then all zeros represent the host portion. Then we have a formula Then let's proceed with our adding operation. And we say that the adding operation simply is a 1 times 1, which is a 1, and then 1 times 0 is a 0. So we want to perform the following. If you have 1 times 1 is a 1, 1 times 1 is a 0, 0 times 1 is a 0, all the way, you end up with these results. The same applies to this, to the other one, and to the other one. So you can see if you convert this one back to the following, we said here the position of 1 in these binary numbers, which are 8, is 128, then 64 is 192, then 128 plus 32 plus 8, this is 1, 1, and 1. The position of this is 128, 32, 8 is 168. Whatever we have is 192, 168.0.0, then 24, and what we have is that the result is what we call the network portion, that one. Then this 0 represents the host portion, and this sign, and then 24, we usually call it the prefix length. Of importance also to understand that in subnetting we can create subnets from the subnet mask. So in the formula for creating the number of subnets For example, if you want any number of subnets, it is 2 raised to power n, where n is the number of network borrowed network bits. And then note, we also have the formula for calculating the number of hosts. It is 2 raised to power n minus 2, where n is the number of host bits. So let's perform a problem on subnetting. You are provided with the following: IP address 192.168.10.0, prefix of 24. Use the IP address above to answer the following questions. How many network bits are required to create 4 subnets? List the 4 possible network address and subnet or the subnet address. Outline the first usable address, last usable address, broadcast address for each subnet address listed in Roman 2 above. So we have the first subnet, the second, the third, and the fourth. And then you have been given this IP address. So in binary, first is to represent this one in binary, and we have it represented here. Then the next one is the subnet mask, which is 255 in binary is as follows. Now, the new subnet mask, as we shall see, is now how do we get it? Remember, we want to calculate the number of borrowed network bits. So you have this formula, 2 raised to power n, which is give us 4. 4 is the number of subnets. So 2 to power n is equals to 2 raised to power 2, which simply tells us the number of borrowed network bits is 2. So the prefix length will change from 24 to, you can see we have borrowed from the host bits, we have borrowed 2 network bits. So this one stands to 1 and the other one a 1. So which means this one has a position of 128, and the other one has a position of 64 from this table, as we can see. So we can proceed. So the new prefix length is 26, and that tells us that now this one had 120. This one had a prefix length of 24, but the subnets that we have a prefix length of 26. So the other question, is that we are required to list the 4 possible network address. This is the second question. At least we have been able to answer that how many network bits are required to create 4 subnets. There are 2, and the formula is what we had. That is 2 raised to power n is equals to 4. So 2 n compares to 2, so we have 2. So the other thing is we need to list the 4 possible network address for this case. Now, I want us to pay close attention to the last bit which we borrowed. It has a position of 64, and that position of 64 is according to the weighted value. This is 128, this is 64. So we are going to increment the network or the host bits portion. Remember what we said about the host. There's something we had said about the hosts. Remember what we said about the host portion. This is the host portion. So we will proceed, we increment the host portion with an increment of the first subnet address will be 192.168.10.0, prefix of 26. So we increment this one by 64. So add a 0 here, 64 in this one. Then also to the next one, 64, add 64, 128, and then 64, 128. You get 192. So we have addressed the other bit that we needed. So at least we know the first has this, the second, we have it there, the third, we have it here, and through this one at least we can achieve, we can reduce the issue of congestion because we are assigning them to different interfaces. Then we are tasked now to get the first. We are addressed to solve the following: the first usable, the last usable, and the broadcast address for each subnet are listed. So again, let's focus on the first subnet address is the one we have as 0. So again, let's pay close attention to the network bit which we borrowed, and then the host bits that we referred to. There were all zeros, other zeros in this last octet is the hosts. Then we have the network bit which we borrowed. So to understand the first host address, from 1, for example, we can see that from 0 we can assign 1 to all the way to 63 to hosts in this subnet. Then the other subnet we can assign any number from 65 all the way to 127. Then the other one we can assign 129 all the way to 191. So that is what we are going to answer using this. So I'm going to use this illustration focusing on the host bits such that these zeros, they are no longer now host bits because they are being borrowed in network bits. So we are focusing on, we are assuming they're all zeros, so we focus on this. We demarcate and we focus on these ones. So the first one that we can assign a host is 1. So that's what we have. And that is what we call the first host address in binary. We are likely to have is the last usable host address. So it means we convert from this one, we convert them to ones and the other one to a 0. Then the broadcast is that we are going to convert all the other ones. So such that if you add all this, we are going to get 62. And if you add all this, you are going to get a 1. And if you add the others, you are going to get 63. So the first one, now we can give it, the answer is, first usable is 192.168.10.1 prefix 26. The other one is 62, and the other one is 63. So for the second subnet, as we have said, the first one will be 65, and the last usable 126, and the broadcast will be 127. For the third subnet address is 129, 190, and then 191. So we have the last subnet which we created, and this is the one. So I would like you to look at this one and try to assign the first usable, last, and the broadcast. So I have been your trainer, Mr. Ngige from Jeremiah Nyaga. If you have liked this presentation, kindly give it a thumb up and also like our channel and subscribe. Thank you.